How will we get around in the future? What could succeed crude oil and natural gas? One option already exists. It has 3 times the energy density of petrol. It's available in huge quantities. There are even around 7 kilos in each of us, and it has a low environmental impact. Hydrogen could be the ideal partner for a greener future. This film is about the unique qualities of this element. How today, hydrogen already drives society and the potential it has for shaping a much greener future. The EU and G8 countries have agreed that the future demands a stricter climate policy and have pledged to halve CO2 emissions by 2050. In this time frame, the number of private cars worldwide will more than double to 2.5 billion. So demand for energy continues to rise while fossil fuels dwindle. We simply can't continue as before. Hydrogen is a clean fuel source and burns without producing any harmful exhaust fumes. Practical applications are being researched at the Vienna University of Technology.
One sustainable solution to climate change is to extract the carbon from fuels and propellants, thereby reducing greenhouse gases by preventing the formation of carbon dioxide released during combustion. Using hydrogen as a fuel source is an excellent solution here. It can be turned into power electrochemically directly in the fuel cell. This means we can secure transport which is completely free of CO2, even for cars.
Hydrogen was discovered in 1766 by a British scientist named Henry Cavendish. By pure chance, he discovered that water consists of hydrogen and oxygen. Hydrogen comes from the Latin hydroganium, which literally means making water. This is why the chemical symbol is H. Hydrogen is the first element in the periodic table, and not for nothing. No other element is lighter. No other element is more abundant in the universe. Hydrogen is pure energy. Perhaps the best example is the sun, 92.1% of which is hydrogen. There's just one problem. On Earth, hydrogen only exists chemically bonded in molecules. In order to produce pure hydrogen, you need to extract the hydrogen from the respective molecule. One way of doing this is with electrolysis, where electricity is used to split water into hydrogen and oxygen. But this requires a great deal of energy. A tankful would be practically priceless. And yet, there is affordable hydrogen on the market thanks to steam reforming. Here, steam is introduced to a fossil fuel, such as natural gas, and heated to 830 degrees Celsius. The mixture is then passed through ever finer filters until only pure hydrogen remains. This is currently the most efficient way to generate hydrogen. However, this method still uses our old fossil fuels. But how else could we possibly get precious hydrogen out of water? Reducing the energy needed to generate hydrogen would be a huge breakthrough. A team of scientists in Great Britain are doing exactly that, looking for a solution which harnesses the power of the sun. In this test tube, hydrogen is being extracted from water. Amazingly, it is being achieved using light alone. These bubbles could herald a real revolution in energy. That is the mission of a team in Cambridge, conducting research at one of the world's best universities, which has produced 88 Nobel Prize winners to date. It is also home to Erwin Reisner, a chemist with ambitious plans.
We need a renewable source of energy. Sunlight is the most obvious source. It is enormously abundant and available all over the globe. It sounds very simple. We have water, H2O, and convert it into hydrogen and oxygen. The problem is we have to combine many different technologies. The most complicated part is to make it very efficient, stable, and inexpensive.
Erwin Reisner's work is trailblazing. Finding and creatively combining exceptional approaches from all of the natural sciences is what is needed. The result could be a solution to tomorrow's transport questions, which is why energy supplier OMV is supporting this research.
Sunlight is the greatest energy source we have on Earth. Harnessing this energy to produce fuel that can power our mobility is very important. I believe we've laid the groundwork, however it will take many years to research and develop further. It's important that we've made a start today.
We look for a catalyst which can facilitate the transformation of water into hydrogen. And much of our work is developing these catalysts which can drive this process very efficiently and cheaply.
The search is on for just such a catalyst. To that end, Erwin Reisner is also taking inspiration from nature. A leaf can achieve something phenomenal: photosynthesis. It grows by taking in CO2 and water and transforms it into energy with the help of sunlight. We can now achieve something similar artificially, splitting water into oxygen and hydrogen purely with the power of the sun. Normally, this requires much more energy, but a catalyst provides a kind of shortcut. It's easier to break the bond between the atoms and would mean that hydrogen could be generated using sunlight alone. Erwin Reisner has been pursuing this research for 3 years at the Christian Doppler Laboratory in Cambridge, together with his talented team of 20 young scientists who hail from 13 countries. Weekends in the lab are a matter of course when researching an energy revolution. The team quickly realized how to use sunlight to generate hydrogen, but the process currently only works under laboratory conditions with modest yields. They are looking for a cheap material which is highly efficient and can be used in a normal environment.
We just use that inexpensive material. I'll say the efficiency is now at like a 1% or even less than 1%. The final goal is make like a 10% or 20% conversion efficiency from solar energy to the chemical energy.
The most important factor in increasing efficiency is the composition and setup of the catalyst. What's more, the reaction needs a dye.
We need the dye to capture the sunlight efficiently and then transport it. The whole reaction behind making hydrogen from water doesn't happen freely, but also requires energy input.
The scientists see how well an experiment has worked with the help of a gas chromatograph, the hydrogen sniffer dog. Weeks of work are validated, or not, by the machine's proclamation.
The worst case scenario, you can work for ages on a catalyst and then it doesn't work. We can't 100% predict what's going to work and what's not. But so this is where we find out whether or not we have good catalysts, and that's why it's so important. And that's why there's so much emotion involved. You're really looking for that tiny spike of hydrogen.
The scientists are already thinking one step ahead. Liquid hydrogen has some disadvantages. For example, it tends to evaporate. Therefore, it needs to be kept under pressure. But a synthetic gas can be produced from hydrogen, and this is a viable replacement for natural gas or crude. It can be used as universally and has the same easy handling. So another goal is to make synthetic gas from the hydrogen generated. Synthetic gas is made from hydrogen and a carbon compound. However, current methods are energy intensive and not renewable. A catalyst could change this. From abundant carbon dioxide and water, the catalyst generates the components oxygen, hydrogen, and carbon monoxide. This would result in the components for synthetic gas, with oxygen as a byproduct.
We would like to transform CO2 into CO, carbon monoxide. This is interesting because we're trying to develop a system which can turn the greenhouse gas carbon dioxide into something useful, preferably with renewable energy. For example, solar power. This can be used to transform carbon dioxide into carbon monoxide. With the help of hydrogen, this can then be turned into fuel in the form of synthetic gas.
The catalyst needs to be made of elements which are very abundant, which means which we have plenty on Earth and which are scalable. So there are, in fact, not that many choices. Of course, there's all these carbon materials, but other materials would be abundant metals such as iron and nickel.
When this theory becomes reality, we will have an environmentally sound, universal energy source. For example, if we use synthetic gas to fuel our cars, the only residual of combustion would be those related to synthetic gas production, CO2 and water. This would create a closed loop.
It would mean we could reduce, almost cut our dependence on fossil fuels. So this means we could reduce carbon dioxide emissions and we could live in a much greener environment.
Cambridge has often been the font of scientific breakthroughs which have fundamentally changed the world. And there are already indicators that history could soon be rewritten once again at the Christian Doppler Lab. The team is highly motivated.
I want to have people from different backgrounds, and then I know, of course, also which expertise I need for the project. And with these factors, essentially, we select people, put them together, see how they interact, and try to develop a very strong group dynamic and group interaction. And that's essentially how it works.
You need to find something new and something creative things every day. And I think the new findings are driven by the curiosity. So I think the curiosity is the most important thing.
You really need the motivation to push things on, to achieve results, to make discoveries. This is why we do what we do.
It's a great atmosphere. We work together and also spend most of our free time together. It's like a school class, a family.
Their motivation helps you become more motivated, and then we all become, hyper-motivated people who do some good research, hopefully, most of the time.
It's tremendously satisfying and exciting to see new ideas, new science coming from these young enthusiastic groups.
But it's a huge risk to fail, yes. But I think we are quite happy to take this risk. So for me, we work on a very big problem. I think if we have a tiny chance of making this reality, I'm very willing to take this risk.
If in years to come we have an environmentally friendly, easy disposable source of energy, this might be thanks to Erwin Reisner's research. But it may still take decades until hydrogen becomes the basis of our energy supply. This gadget is environmentally friendly, but it still runs on classic electrolysis and not with a high-tech catalyst. These children had to save money for a long time to buy this toy. Building a gadget like this is quite costly, which is also the reason why full-scale hydrogen cars have not been that successful. Producing these vehicles is still very expensive, making the purchase price too high. However, the technology would be suitable for everyday use. Energy from hydrogen can already be used on the road with a fuel cell system which powers an electric engine. This relies on a chemical reaction which generates electricity from hydrogen. Each fuel cell consists of two plates separated by a membrane. Oxygen from ambient air is supplied to one side with hydrogen on the other. The positive particles of the hydrogen atoms are able to pass through this membrane. The negative particles cannot pass through. However, atoms need an equalizing charge. To achieve this, the electrons must change path, and this creates an electrical current. The end products from the chemical reaction are power for the drivetrain and H2O, that is, pure water. This is the only emission produced by this mini power station.
In principle, the fuel cell where this energy transformation is taking place is far more efficient than an internal combustion engine. The various extra parts which are needed lead to a sharp rise in efficiency in real vehicles, compared to the classic drive technologies we're all familiar with.
Vehicles with fuel cells are already in use, although only in an industrial context, such as at this logistics company in Austria.
There, the forklifts have electric motors, and refueling time is naturally much shorter with the fuel cell system. This means that the vehicles are recharged in just a few minutes and can immediately get back to work.
The few fuel cell vehicles currently on the road are part of research projects. One real-world experiment involves Austria's first public hydrogen fueling station, and it will probably take a while before the crowds come flocking.
Hydrogen is a new product in the traffic sector and will not experience a real surge until around 2025. This is the year when almost all car manufacturers will need so-called zero-emission vehicles in order to meet their CO2 commitments. There are plans to build around 400 filling stations in Germany in the next 10 years.
Things will be tough for hydrogen as long as there is competition from fossil fuels. It needs to be an equally valid alternative to petrol and diesel. This has already been achieved at the pump, where filling up time and costs are competitive.
The price point of hydrogen today broadly corresponds to the equivalent in standard fuel. This means that every kilometer driven with hydrogen costs the same as a kilometer with petrol or diesel.
OMV already produces 100,000 tons of hydrogen in Austria each year. This volume of hydrogen could provide energy for 850,000 cars. But the cost of the fuel cells is holding back hydrogen-powered vehicles. However, the first car manufacturers are starting mass production, with higher numbers leading to lower costs. Today's industrial hydrogen production does have an environmental impact, despite all of the arguments in favor of fuel cells. But there must be a greener way for this energy source to conquer the near future. There's renewable energy available from wind farms and solar plants. If you put these energy sources together with hydrogen production, we'd have a pretty smart solution. Today, wind turbines generate electrical power, which can be fed into the grid. When strong winds generate too much power, or if demand is low, it can be difficult to feed in. And when the wind drops off, there isn't enough energy to maintain supply. One solution would be to use the surplus energy to produce hydrogen directly on site via electrolysis. The hydrogen could then be stored and either be used directly or via fuel cells to feed into the grid at any time. A plant like this will soon be built at a filling station near Vienna. Here, energy company OMV will test its new production technologies and find out how suitable the existing natural gas network is for storing hydrogen.
The natural gas network has two things in its favor. One is that the network itself provides storage. The other is that it can serve as a highway. I can use infrastructure which already exists to transport renewable energy using the gas network. We expect that after the energy transition, about 2050, we have to store about 10% of the power demand to provide a seasonal or short-term supply.
One of the architects of this principle is Michael Sterner. He's a lecturer and researcher at the Regensburg University of Applied Sciences. But his ideas go even further and are known as power to gas. With power to gas, you use hydrogen and renewable energy to make a synthetic gas. This gas is easier to store and has many more applications than pure hydrogen.
When I published my doctorate, which was the first work on power to gas, I was laughed out of the room. They all said Sterner is crazy. But slowly they're all coming to understand that the gas network is the infrastructure with the largest storage capacity in Europe. Everything is already available, and that makes it the ideal complement to a power sector highly dominated by electricity.
Making power-to-gas facilities more widespread is being hampered by legal regulations and the expensive setup. The latter is set to change soon.
I believe that the costs of this technology will halve in the next 10 years. There's a lot of potential for cutting costs. Imagine if you were to build the first car by hand. Nothing is automated. And that's where there's huge potential for slashing costs.
There are other believers in this visionary concept. Within 4 years, around 20 power-to-gas plants have started testing in Germany alone. One of the largest has been operating in Bavaria for many months without a hitch.
R&D projects almost never run as expected. There are always surprises, but this time we've been pleasantly surprised. We legitimately hope to achieve the level of quality in commercial application which will allow us to store gas directly in natural gas pipelines. The next step will be a facility for demonstration, which will be 4 times the size of this facility and will also be the next step in the commercialization of this technology.
Innovators of these technologies are also found in Austria. For example, at the Hydrogen Research Center, where work is being done on projects such as developing fuel cell vehicles.
If we look to the future, I'm certain that hydrogen will play a major role. Hydrogen is the future, whether it's for generation in power-to-gas plants, for storage in the gas network, or for use on the road. Electromobility and biofuels won't be enough to replace all of the oil we'll need to get around.
Hydrogen is the universal energy store, and we believe it will play a massive role in the future.
You can talk about climate change, you can talk about reducing carbon dioxide emissions, etc. But for me, it's not really the critical question, to be honest. It's just a general assumption that society should be sustainable.
It's critical we find solutions capable of meeting climate goals in 50 years. We also want to use field tests to prove that this technology is environmentally friendly as well as consumer friendly.
If this is successful, if my experiment is successful, then everything in society, like infrastructure and then the lifestyle, can totally be changed.
Working on this technology is a lot of fun.
Energy and mobility rule our lives. But this personal freedom and availability of energy could prove to be luxuries for the next generation. Hydrogen offers many new applications in energy supply. Some of these may well be part of our everyday lives in just a few years, while others still sound like science fiction. But when these ideas become reality, they will change the world.